Hi everyone, this is Purnima Mahalingam. In this video lecture series number 4 of electrical machines and drives, today we are going to discuss about speed control of AC motor. Okay, come let's go into the video. So in this video, we are going to discuss about what introduction about speed control of AC drives, and we have what is a frequency control and what is VFD and what are the main components of VFD and schematic diagram of VFD and purpose of VFD and how energy is saved using VFD, what is advantages, disadvantages and applications. In this video, we are going to discuss about these are the components. In this series, in next series, we are going to discuss about these components. Okay, come, let's in the video. So first introduction, we are speaking about VFD. What is VFD is a variable frequency drive. This controls the speed of the motor, specifically in the three-phase motor. To be better understand a VFD, it is examine line the motor they control. Okay, the most common commercial HVAC systems requires powerful motors and often operates on a three-phase power. The standard methods of our electrical power distribution system is its efficiency. Okay, the three-phase motor is cheaper to operate than single-phase motor because it is used less current. The main thing is it is less current. That less current often result in reduced wire size and cost, etc. So especially where large motors requirements are necessary. A VFD eliminate high inrush current when standard motor is turned on. It draws a very high amount of current for a very short duration of time. Okay, a variable frequency drive is designed to slowly start, therefore to prevent inrush current. To reduce the stress on a component of a motor, the external motors of it extend the motor life. Motor life is extended. The VFD controls the speed of three-phase AC motor while resulting in the energy saving. It saves energy because the motor does not require as much the current at a low speed. So the solution is the VFD. That is the variable frequency control. The main solution for the control at low speed is variable frequency control. Okay. Now, how the speed of the induction motor is controlled by frequency control method. Here the speed, first coming with the synchronous speed. So see, we know the synchronous speed formula NS is equal to 120 F by 120 F by P. So F represents frequency and P represents number of poles. So it is a unit is RPM, rotation per minutes. Okay, therefore the synchronous speed of a motor in terms of operating speed of a motor depends upon the frequency. But since the voltage equation is that when the voltage, the back EMF equation equal to voltage equation. So here the voltage equation, back equation is almost same. So that is 4.44 F phi m, flux into frequency into speed at primary side, and kpdp. So the flux is maximum flux is V1 divided by F, and the equation is arranged like this. And finally the flux is depends on the voltage and frequency. If the frequency get decreases, what happen? Automatically the flux get increases. That is indirectly proportional. The flux and frequency are indirectly proportional. Okay, now coming to the speed control is achieved by changing the frequency of the supply voltage should be also simultaneously changes. The frequency also should be changes simultaneously. This is because of the frequency, supply frequency is reduced, keeping the applied voltage constant, that the flux is increases. If the supply frequency is reduced, what happened? The supply frequency, the flux is increased. So previously we have told that if the supply frequency is phi is equal V by F. If frequency get reduced, what happens? Automatically flux get increases because it is inversely proportional. The flux and frequency are inversely proportional. If the flux increases, core losses will increase and reduce the efficiency. Hence, need to vary voltage to keep constant flux. Okay. If the frequency is increases, the flux gets increased, the vice versa. Therefore, that reduce the development of the torque. Therefore, it is important that the frequency changes, devices should change frequency and voltage simultaneously as a direct ratio. Okay. Thus, the speed control of the induction motor by changing frequency method, we require not only variable sources but also the variable voltage sources, not only the variable frequency sources but also the variable voltage sources. Okay, so now coming to what is VFT. Coming to what is VFT, we know that VFT is a variable frequency control, is used to control the speed of induction motor through changing the input frequency and voltage. Changing the input voltage frequency. Here we can see the 50 hertz power supply. Here we can see the VFT. What happens? So we have a frequency of equal amplitude and equal phase. See, we can see now what happens to motor variable frequency. Here we can see the variable in time period and variable in frequency and variable time period. So here we can see the variable frequency. Here we can see the constant frequency. Here we can see the variable frequency. It varies both the frequency and amplitude. It varies both the frequency and amplitude, and it both the frequency and amplitude of an AC waveform being delivered to the motor, saving money in the electricity. Okay, so that's all. With this, we can end up with this video. So today we have seen what is introduction, what is frequency control, and what is VFT. And remaining part we can discuss in upcoming classes. Thank you so much.